Hi guys, welcome to lesson 7 of your math lessons. So last time we met, we talked about multiplication as a comparison, and this time we're going to be talking about multiplication in word problems. And so that may look like solving an equation, that also may look like doing a comparison, but we're going to be looking at different approaches for solving multiplication word problems. Woo! Yep, that's what happens at the end of the day is my hair starts going crazy. Okay, so let's go ahead and start on page 126. The problem says Janelle's Market sells bags of 8 oranges. Simon needs 5 times that amount. Write and solve an equation to find the number of oranges Simone needs. So the first one says there's a model that says you can use a bar graph to help you understand the problem, and then you can also make an equation as well. So if we were using a bar model, we would start, so we know that Janelle's Market sells oranges in bags of 8, but Simone needs 5 times that amount. So we'd have 1, 2, 3, 4, 5, each of those 5 bags with 8 oranges in it, right? So 8, 5 times 8, 8, 8, 8, and 8, 5 times. You can also go ahead and show that as an equation. So we would have our 5 bags of 8 oranges equals the total number of oranges that is needed, right? Which is what we're trying to solve for. So let's go ahead and turn the page to page 127 and we'll work through some of the questions. So number 1 says, you do not know how many oranges Simone needs. What symbol on the bar model shows how many she needs? So you can see on the previous page, there's our little curly parentheses with a question mark underneath it. So that's showing the unknown amount. We want 5 times the amount of oranges in bags, but we don't know how many that would be. So the question mark is telling us what, representing the unknown. Number 2 says, how does the bar model show how many oranges are in one bag? So our first box shows how many oranges in one bag by having 8 as our basic unit, right? So we have 8, and then we have the 5 times the 8 that Simone needs. Number 3 says, how does the bar model show how many oranges Simone needs? Well, we have the 5 boxes of 8 that shows how many Simone needs. And number 4 says, how can you find 5 times as many as 8? We can multiply 5 times 8 to find the answer. Number 5 says, write an equation using numbers to show how many oranges. So that would be our 5 times 8. And if we were to solve that, we could go ahead and count by 5 8 times because 5s are nice that way. So 5, 10, 15, 20, 25, 30, 35, 40. We would have 40 total oranges that Simone would need. All right. Your job, go ahead and turn to page 128 in your packet, and we're going to do numbers 8 and 9. In fact, you're going to do numbers 8 and 9. You're going to pause the video and do numbers 8 and 9, and then restart the video. Not restart the video. Sorry, no, not from the beginning, but just unpause it and check your answers then when you're done. All right, so hopefully you just did numbers 8 and 9. We're not going to cover number 10, but if you did number 10, awesome job. So number 8, Neil and Vincent collect cans. So remember our strategies for working through word problems. We don't have any number. We're looking for numbers to circle, question to underline, boxing in keywords. Now, number 8, Neil, the first sentence that says Neil and Vincent collect cans, that's not really important math information for us. So that's giving us some information, but not the important math information for how to solve this problem. Neil collects 10 cans. Okay, so that's some information. So I'm going to go ahead and start setting it out as a bar model where we have 10 cans is our base. And Vincent collects 3 times as many cans as Neil. So Neil collects 10 cans. Vincent collects 3 times as many. So he's collecting 10 3 times. So if I were to go ahead and set up my problem, this might be how I would set it up. But if we're looking for information, we would circle 10 and we would circle 3, and then we would box in times, right? Because we're not talking about 3, we're talking about 3 times the same amount of cans. Write an equation with an unknown to find the number of cans Vincent collects. So we have 10 cans that Neil collected. Vincent collects 3 times as many cans. And so we would be finding, so our answer would be unknown at this point, but we could go ahead and solve 10 times 3 would be the same as counting by 10 3 times 10, 20, 30. 10 times 3 equals 30. All right? So Vincent collects 30 cans is how we would answer that problem. Now, number 9, Mimi eats 6 times as many raisins as Mary. So we don't know how many raisins Mary has eaten yet, but we know that Mimi eats 6 times as many raisins. So for right now, I'm going to leave this one blank because we don't know how many raisins Mimi ate. We do know how many raisins Mary ate. She ate 6 times as many. Wait, do I have that? Nope, sorry, I have that backwards. So we know that Mary ate a certain number of grapes. We know that Mimi ate 6 times as many raisins, rather. Now in the next sentence, Mary eats 9 raisins. So now it's telling us that Mary eats 9. Mimi eats 6 times the amount that Mary ate. So we have 6 times 9. It says, write an equation with an unknown to find the number of raisins Mimi eats and then solve the equation. Show your work. So first we would have our 9, and we would have our 9 6 times to equal our unknown, right? So the problem we're trying to solve is 9 times 6. Mary ate 9 raisins. Mimi ate 6 times that amount. How many raisins did Mimi eat? We are then going to go ahead and write our equation a second time, but this time we're going to solve. We're going to use our fancy 9s trick. 1, 2, 3, 4, 5, 6. I'm going to put my 6th finger down. Now I have 5 on my left hand. That's going to be my 10s. 4 on my right hand. That's going to be my 1s. So Mimi ate 54 raisins, which sounds like a lot, and then you remember that they're raisins. So they're a little bit. Okay. Go ahead and turn to the next page, pages 129 and 130. We're going to be covering in our practice session on Wednesday. Go ahead and keep turning to page 132. Page 132, we're now using a different problem. Juan finds 3 times as many shells at the beach as Jeremy finds. Juan finds 24 shells. Write and solve an equation to find the number of shells Jeremy finds. So now, instead of us trying to solve our problem, now we're looking for a missing number in here. So we've changed our problem. We still have nicely, why am I blanking on the word? Words that have the same letter to it. Yeah, it'll come to me after I'm done recording this lesson. Cool. I'll call you guys in the middle of the night to let you know. All right, so Juan finds 3 times as many shells at the beach as Jeremy does. So we're going to say that Jeremy is finding a certain number of shells that we don't know yet. And Juan, alliterative, there it is. I didn't have to wait until the middle of the night. Alliterative names because they're starting with the same letter. All right, so we have Jeremy and Juan. So Jeremy finds a certain number of seashells. Juan finds 3 times that many seashells. We don't know how many seashells they found, but we do know that Juan found a total of 24 seashells. So now our question mark is here, right? We don't know how many Jeremy found. We do know that Juan found 3 times that amount and that Juan found 24. So we have enough information that we can start piecing together our answer. So let's go ahead and start. We don't know what we're starting with. A certain number of shells 3 times is going to equal 24. So we could write an equation to show it that looks like this. And you'll see on the second model it that they've done something similar. They said 3 times Jeremy shells equals Juan shells. And they've written it with S standing in for shells as 3 times S equals 24. So whether you write it with a question mark or a blank, whether you write it with a letter standing in for an unknown number, when we write letters to stand in for unknown numbers, that's how we start working towards algebra. But either way you write it, we're solving for an unknown number. We do not know what number, as of yet, multiplied by 3 is going to make 24. So let's go ahead and turn the page to see how we can work through the steps to solve this problem. All right. Number 1, you do not know the number of shells Jeremy finds, right? Unknown number of shells. What part of the bar model shows the number of shells Jeremy finds? So our box with the question mark shows the shells that Jeremy found. We don't know how many shells Jeremy found. We just know that Juan found 3 times as many. Number 2, how does the bar model show how many shells Juan finds? Well, Juan found 3 times the question mark, 3 times the amount of shells that Jeremy found. So we're going to have those 3 boxes in the bar model. Number 3, how does the bar model show that 24 is 3 times the other number? Well, we see that we have the question mark 3 times is equal to 24. So the total value is 24. Now number 4 says, how can you find what number times 3 is 24? So remember, that's like solving for S down here. I'm going to go ahead and rewrite it as S 3 times, S standing in for the number of shells. So instead of a question mark, we're thinking of it as S, an unknown number of shells. 3 times equals 24. So that would mean that if we took 24 and divided it by 3, because multiplication and division are inverses, we would get how many shells Jeremy found, right? So our 24 shells that Juan found divided into the 3 times that that Juan found it over Jeremy, and we would get our first number. So let's go ahead and think through our facts. 24 divided by 3, I'm still going to think about this as 3 times what number equals 24. I know that 3 times 7 is 21. That's just one of those facts that is indelibly carved into my brain. So that's not quite there, but it's really close, right? So I'm going to go ahead and use that as a marker. I'm going to say, okay, 7 times 3 is 21, and that's close. So let's try 8 times 3. That would be adding 3 more, 21, 22, 23, 24. Yes, that's right. So if 7 times 3 is 21, 8 times 3 must be 24. Therefore, 24 divided by 3, our unknown number S is going to be 8. So number 5 says, write a division equation using numbers to show how many shells Jeremy finds. We would have 24 divided by 3. We've discovered that that is 8. So therefore, Jeremy finds 8 shells. There we go. All right, let's go ahead and look at the first 2 problems on page 134. I want you to do the problems first, pause the video, and then come back and review your answers. All right, now that you've done numbers 8 and 9 on your own, we're going to go ahead and review your answers. Monique and Wint read the same book. Monique reads 63 pages on one weekend. She reads 7 times as many pages as Wint. Write an equation with an unknown to find the number of pages Wint read. Then solve the equation and show your work. So I'm going to start with a bar model because I think that this is the easiest way to go ahead and take some of that information and par it down. First, though, I'm going to go through and circle the numbers. The numbers that I have are 63 and 7, that key word there being times, right? So we have 63 pages is 7 times an unknown number of pages. So I have Monique, who read 7 times 1, 2, 3, 4, 5, 6, 7, yep. We'll just expand it a little bit to make for a total of 63 pages, right? And we have, is it Wint? Yep, Wint, kind of a cool name, read a certain number of pages. Now Monique reads 7 times as many pages as Wint, so that's represented by our bar model here with the 7. So here we have Wint's number of pages. I'm going to go ahead and let P stand for the number of pages, and then I'm going to have P times 7 is going to equal 63, right? So I'm going to write that as an equation. P times 7 equals 63. So now I need to think about 63 divided by 7 is going to equal P, and I can solve for P. Well, again, I'm going to use the facts that I know. I know that 10 times 7 is going to get me 70. Now that's not 63, but it's pretty close. So I'm going to take one of those 7s away, and I'm going to say now I have 9 times 7. I'm also going to use my nice little 9s trick. 1, 2, 3, 4, 5, 6, 7. Put down my seventh finger. I have 5 and 1 more on the right side, or I'm sorry, on the left side of my finger that's down. So that would be 6 10s. You have 3 on the other side, that's 3 1s. So 63. So I now know that P is going to be 9. 9 times 7 would get me 63. Therefore, 63 divided by 7 is 9. And so each of these, we're going to just turn them around, and they're going to go from P's to 9s, showing us that 9 7 times is 63. Therefore, Wint read 9 pages. All right. Number 9, the winning baseball team scores 4 times as many runs as its opponent. The winning team scores 8 runs. Write an equation with an unknown to find the number of runs its opponent scores. So again, we're dealing with our unknown. We don't know how many scores the opponent, how many runs the opponent makes, but we do know that the winning team scores 8 runs, and that is a total of 4 times as many runs as the opponent. So we're going to let R stand for runs. We have R times 4 equals 8 runs altogether. So 4 times R is 8. There we go. So I'm going to think about it as 8 divided by 4 equals R. I know that 2 times 4 equals 8, so I know that R is going to equal 2. So the winning team scored 8 runs. The losing team, their opponent, scored 2 runs. All right. Go ahead and turn to the next page, pages 135 and 136. We will be covering in our math lesson on Wednesday again. Pages 137, 138, 139, and 140. You are welcome to do for a little extra practice, but that does conclude this lesson. I will see you guys on Wednesday to do a little bit more practice with that. Okay, bye.